Welcome everyone in the theory of computation of first internal solution. In this, our first question is construct a finite automata to accept the set L of all strings over 0, 1 ending with 0, 1, 0. So we have to construct a deterministic finite automata which have strings over 0, 1 and it should ending with 0, 1, 0. For this, our DFA can be defined as DFA is a 5 tuple given as m equals to q, sigma, delta, q0, f. Q can be defined as a finite set of states, and sigma can be defined as a finite input alphabet. Then we have q0 that can be defined as the initial slash starting state, and q0 is in q. Then we have f that can be defined as a set of final slash accepting states which is a subset of q. Then we have delta. It is a transition function which is a total function from q multiplied by sigma to q. For our question we have q equals to, that means set of states equals to q0, q1, q2, q3. Then we have sigma. It is a input alphabet, that is 0, 1. We have a start state, that is q0, and we have a final state, that is q3. That's our diagram of finite automata that accept string which is ending with 0, 1, 0. In this, you can clearly see that we are starting from q0. This is the initial state. When it receives 1, it again back to q0. If it takes 0, then it goes to next state, that is q1. If it takes 0, then it again on the same state, that is q1, and if it accepts 1, then it moves to q2. If q2 takes the input as 1, then it moves back towards q0, and if it takes the input as 0, it goes to q3, and at q3 if we have 0, it moves back to q1, and if it has 1 as an input, it moves back to q0. Our state diagram is, if we have a state on q0, our input is 0, then we are on the next state, that is q1, and if we have an input of 1, then we are on the same state, that is q0. Then we have on the next state q1. If our input is 0, we are on the same state q1. If our input is 1, then we are on the next state, that is q2. Then our next state is q2. If our input is 0, then we are on the next state, that is q3, and if our input is 1, we go back to q0. And if our state is q3 and input is 0, we are on the move back towards q1, and if our input is 1, then we go back to our back state, that is q0. This is all about DFA, deterministic finite automata. Our second question is construct PDA to accept the set of L of all strings over 0, 1 ending with 0, 1, 0. So we have to construct a push down automata, and it can be defined as Q, then we have sigma, then we have T, then we have delta, then we have Q0, then we have Z0, and we have F. We have defined the delta by the following rules, that is given as rule number 1. We have delta bracket q0, 0 and z0, then it equals to q0, 0, z0. Rule 2 is delta in brackets q0, 1, z0 is equals to inside q0, 1, z0. Then we have rule number 3, delta given as delta in brackets q0, 0, 1, z0, that is equals to inside q1, 0, z0. Our rule number 4 is given as delta in brackets q0, 1, 0, z0 equals to inside of q1, 0, z0. Then we have R5 given as delta brackets q0 comma 0 comma 0 z0 is equals to in set of q0 comma 0 0 z0. Then we have rule number 6, delta as q0 comma 1 comma 1 z0 equals to in set of q0, this is an empty sign, this belongs to an empty, and z0. Then we have rule number 7 that give as delta in brackets q0 comma 0 comma 0 equals to in set of q0 empty and z0, that is q0 0 1 0 and z0. So by rule number 1, our push down automata's first step is q0 comma 1 0 comma 0 z0, and by rule number 4 we have q1 comma 0 comma 0 z0 by rule 4, and by the rule number 7 we have q1, and again it's a empty symbol, and q0. By this we got the push down automata to accept the set of all strings over 0 comma 1 ending with 0 1 0. This is our question number 3rd. In this we have to construct a Turing machine to accept the set of L of all strings 0 comma 1 ending with 0 1 0. For this we have constructed a Turing machine. Here we are starting from q0, it is our initial state. On q0, if our input is 0, we have 0 q0r, that is this 0 q0r, we are on the same state 0, then we are q0 and we move towards right, that is r. Then we have 1, if 1 comes as an input, it gives as 1 q0r, we are on the same state 1, and we move right towards next state. Then we have an input of b, it gives as 0 q0r comma 0 q0r, that is 0 0 r, it returns back to q0. When we have bl as an input, means we have input of b and we move towards left. Then we have q1, we are on the q1 state, that is given as b q2l, and on input of 1 it gives as 1 q5l. Then we are on the uh, next state, that is q2, it is given as on the input of 0, we are on 0 q5l, 0 0 q5l, this state, and b q3l on the input of 1, that is we are on the next state, this state q3. Then if we have an input of 0 on state q3, we will reach through b q4l, means fourth state 0 bl, and if we have an input of 1, we are on the q5 state, that is 1 q5l, and left is blank. This is the Turing machine to accept the set of L of all string 0, 1 ending with 0, 1, 0. Then we have our next question, construct a Turing machine that accepts the language 0, 1 star plus 1, 0 star. It is starting from Q0 and ending on Q6. Its state transition diagram can be given as our state is Q0. On the input of 0, we are on X Q1 state and right move. Then we have, if input of 1, then we have Y Q5 state and right move. Then we have input of B, then we are on Q4 state and moves right. If we are on Q1 state, our input is 0, then we have 0 Q4 and R. If our state is Q1 and input is 1, then we are on Y Q2 R. If input is B, then we are on B Q3 R, that it moves towards right. Then Q2 state input is 0, we have 0 Q4R. One input given as y Q2R and B input gives the value of y B Q3R. These two are blank because it doesn't move anywhere. When we are on the Q5 state, and our input is 0, then X Q6R and input is 1, then 1 Q4L, then if input is B, then B Q3L, and it is the last state Q3 given as on the input of 0 as X Q6R, 1 Q4L and B Q7L. This is the last question in which we have to construct a push-down automata equivalent to the following CFG. We have given a grammar, context-free grammar, and we have to test whether 0, 1, 0 raised to 4 is in n of a. So our a is equivalent to q, then q comma q 0 comma 1, then s b 0 1. It is taken from this, and we have delta q s and question mark. Then we have production rule for the delta can be given as these rules. Rule 1 as rule 1 says that delta q comma empty comma s given is equals to set of q comma 0 bb, and q, and rule number 4 also says that delta q comma 1 equals to set of q comma empty. Then we have to test this 0 1 0 raised to 4, that is 0 1 4 zeros against push down automata. So we have taken delta q comma 0 1 4 zeros comma s equivalents to s delta given as q comma 1 0 1 4 zeros 0 bb. By rule number 1 we have delta q comma 1 4 zeros and bb. By rule number 3 we have delta q comma 1 4 zeros and 1 sb. Then by rule number 2 we have delta q comma 4 zeros sb. Then by rule number 1 we have delta in brackets q comma 4 zeros 0 triple b, and R3 by rule R3 we have delta Q0 comma 3 zeros 3b, and by rule R2 we have delta Q0 comma 3 zeros and 0 bb. We have by rule number R3 delta in brackets we have Q comma 0 0 comma bb. By rule number R2 we have delta q comma 0 0 comma 0 b. Then we have by rule number 3 q comma 0 comma b. Then by rule number 2 we have delta 0 comma 0 comma 0 q comma 0 comma 0. Then by rule number R3 we have a delta q comma empty state, that is we have accepted this by 0 1 0 raised to 4 is accepted by the PDA. Thank you everyone for watching this video.